In this session, we'll be discussing the natural resources that we are bestowed with. The human beings which are living on this earth, they have been bestowed so many natural resources. We'll be having a look at that, and then in some of the coming sessions, we'll be discussing some of these more prominent resources in more detail. So today I'll only be introducing you to the natural resources available to us on this earth. See, the resources for human use are provided by the following spheres or the sources. So whatever resources we have for our use, for the use of the humankind, we actually are able to obtain these resources from the following spheres or the sources. So what are the sources or the spheres? We know them as lithosphere, hydrosphere, atmosphere and biosphere. We'll be having a brief look at all these spheres or all these sources, which together provide us various natural resources for our sustenance, so that we can sustain our lives for our consumption. So the sources, as I said, are lithosphere, hydrosphere, atmosphere and biosphere. Now please understand that spheres are connected through cycles. They are different spheres or different sources, but they are connected through cycles. I'll give you an example of a cycle which connects three of them. This is the hydrological cycle. Hydrological cycle basically connects the lithosphere, hydrosphere and the atmosphere. You might have read about this. Hydrological cycle is also known as the water cycle. Absolutely correct. So you might have known about this already, might be knowing about this already. So if you look at the hydrological cycle, what happens is, see, this is a water body here. From water body, the water gets evaporated. Then there are plants. This vegetation is also there. From the leaves of the vegetation, some water gets vaporized and then again it also evaporates. So that particular process is called transpiration. Evaporation is conversion of this particular water from liquid to vapor form, while transpiration is basically from the leaves of these plants. So that is the difference between transpiration and evaporation. And then once this liquid which is there in these water bodies or in the leaves of these trees, when this liquid evaporates, it forms cloud cover. It evaporates, it becomes water vapor. It changes its form from liquid to vapor and it becomes water vapor, and then this forms cloud cover. And this transpiration and evaporation is possible because of the sunlight, because of the heat generated by sunlight. So now this water vapor is formed, then this water falls down as precipitation. It could take form of rain or it could take form of snowfall, and this again falls down on the land in form of precipitation. This precipitation will then further go on to provide water to this water body, and some of the water would seep down. The term used here is infiltration. This water would seep down. You see that this is the ground level, which has been shown by green color. This is the soil beneath the ground, and this is the groundwater, which is below the surface. So this is the groundwater, and this water which is falling down is basically infiltrating into this soil layer, and it is percolating down, and then it is again recharging the groundwater level. So this is how the whole water cycle functions, and the water actually moves from one particular sphere to the other. We saw that from the hydrosphere, this is the hydrosphere part, and this is the lithosphere part. It moved to the atmosphere part. Now this is got to be the atmosphere part. This is the lithosphere part, and this is the hydrosphere part. And from atmosphere again it is coming back to the lithosphere, it is going to the hydrosphere, and this way the water is getting circulated across the three spheres. So that is what I meant by saying spheres are connected through cycles. So this is one cycle, the hydrological or the water cycle, which connects the lithosphere, hydrosphere and atmosphere. Okay, now let us talk about the lithosphere. This is a diagram of lithosphere, we are somewhere here, right, on the surface. But you can understand that the lithosphere consists of the land part which forms the earth, right? This is the land part which forms the earth, and if you look at the various layers which are there, the topmost layer is called the crust, and we basically live on the topmost part of the crust. So the land beneath our feet is basically the topmost part of the crust. So the crust may extend from 0 to 100 kilometers. So this is what has been shown here. Now this whole part, this has been shown by this particular diagram also, this whole part till this point is the mantle, and the remaining is called the core. So this is the outer core and this is the inner core. This portion is the outer core and this portion is the inner core. The depths at which the crust ends is around 100 kilometers. From 100 kilometer below ourselves to almost 2900 kilometer depth. So this is the depth of the mantle. So the mantle exists at a depth of 100 kilometers. It starts at a depth of 100 kilometer and then it continues till 2900 kilometer, and from 2900 kilometer to almost around 6400 kilometer, which is the radius of the earth. Now you would recall, this is the core. 29 to 5100 kilometers called the outer core, and the 5100 kilometer depth to around 6400 kilometer depth is called the inner core. Is this fine? Now, so this is what lithosphere consists of. So this is the structure of the lithosphere and what are the various layers in the lithosphere, right? Fine. Now if you look at what all does it provide, it provides rocks. Rocks are available on the lithosphere only. The rocks are then broken down to form soil. You would have probably read earlier also, there are various agents of erosion like wind, like water. They break down the rocks, and when the rocks disintegrate they form soil. Why is soil important? Soil is important because ultimately we cultivate with the help of soil. Then the soil also has some micronutrients. Micronutrients are elements which provide nutrition to the plants that grow up in the soil. So these micronutrients are very much necessary for the plant growth. This is also provided by the lithosphere. Then the lithosphere also provides us stone and sand which can be used for construction. It can provide us minerals, various ores. For example, hematite is an ore of iron, you might be knowing, and you can extract iron using hematite. So these ores are present in the lithosphere which can be used to extract various elements which can then be used in industries. Again, the sources of energy like coal, crude oil, natural gas, for example, they are also provided by the lithosphere. They are only available in the lithosphere. So you have to do what? You have to basically dig the lithosphere, the upper crust, to obtain coal. Likewise, you have to dig the crust to harness crude oil which is available beneath the earth surface. So these all sources of energy which we used in industries, which we use for other purposes, transportation also, they are also made available by lithosphere. Is this fine? Now let's have a look at what all does the lithosphere contain. It contains microscopic flora. Now remember, for all the time to come, flora means plant, while fauna means animals. Microscopic means very small. Microscopic means very tiny in size, very small in size. So that kind of flora. Likewise, small soil fauna means those species belonging to those organisms which belong to the animal species, which basically are animals, but they are of very, very small size. We can, for example, earthworm is one example that suits this particular definition, small soil fauna. So the lithosphere and the topmost layer of the lithosphere contains the microscopic flora and small soil fauna and fungi. And these microorganisms in the soil and the microscopic flora and the fauna and the fungi, they are actually instrumental in decomposing the complex compounds into nutrients. For example, what happens if you dig up a garbage dump and you put in all the rotten vegetables there, what will happen? And if you look at, and then you cover it up, what will happen 2 years down the line? You will find that the rotten vegetable which you had put in that garbage dump in your kitchen garden, that those rotten vegetables have now got converted into some other form. So this is basically decomposition taking place. So decomposing is basically breaking down of complex compounds which are present in food, which are present in leaves. So they are broken down into simpler elements, and these elements then further provide nutrient to the soil. So the vegetable, the rotten vegetable that you have stored, that you have put in the garbage dump in your kitchen garden, what will happen? It would be broken down. It would be broken down by these organisms into smaller elements, into more simpler elements. These elements would then provide nutrition to the soil. Okay, you might have seen people using cow dung cakes, gobar, in their fields. What happens after that? Why do we do that? Basically, the organisms which are there in the soil, they will break down this complex compound. The dung cake that you are using, the dung which you are using as a manure, so it will break down this complex compound into simple elements. It would convert it into carbon and nitrogen, and this would actually provide nutrition to the soil. So this is how these organisms which are available in the lithosphere or in the soil, they decompose the complex compounds. Like I have taken up the example of the dung cakes that you use, the manure, cow dung manure that you use, and they convert it into simple elements which then provide nutrition to the soil. So this is again a very, very important role, because until unless soil is provided with nutrition, you cannot have natural vegetation, because the vegetation requires some nutrition which it extracts from the soil only. So you understand that this is a very important function played by these organisms. Then let's have a look at the upper crust. Upper crust is, it basically extends till 6 to 7 kilometers depth. It has 92 elements. So all the elements that you use, all the natural elements that you use, and all the natural elements which are then further used as raw material for producing more compounds, they are found in the upper crust. We mine them, and if you look at the composition of the upper crust, you would find that most of the upper crust is comprising of oxygen. 47% of the upper crust is oxygen. Then 28% is silicon, aluminium is 8%, iron is 5%. Then we have got smaller quantities of sodium, magnesium, potassium and calcium. And that is the reason why this particular layer, the topmost layer of the crust, is called Sial. Sial stands for Si plus Al is silicon plus aluminium. So it contains silicates and aluminium. Likewise, the lower part of the crust is known as Sima, silicon and magnesium, right? Likewise, this core, it is known as NIFE, N-I-F-E. Ni stands for nickel and Fe stands for iron. However, we have not been able to dig up to this particular depth. We do this using, we find out the composition of this particular core, which is at a depth of 2900 kilometers. We have not been able to dig up to this particular level. So how do we found out the composition? How did we find out the composition of this particular core? There are so many scientific techniques that we can use for this purpose. For example, earthquake waves can be a good source of information about the composition of earth, and so using these kind of technologies, we have found out the composition of the core. We have not been able to dig it up. We have only been able to find out using these kind of technologies. So this is how the lithosphere looks like. Just one last thing. See, as you go inside, as you go deeper in this lithosphere, you will find that the temperature will also increase as well as the pressure. So the temperature and the pressure will both increase as you go down, which means that this is perfectly fine. When the temperature increases, something converts to liquid. So that is perfectly fine. So this outer core is liquid. How is this inner core? The central part of the lithosphere, the innermost part of the Earth's lithosphere, is solid. This is solid because of the high pressure. So because of the high pressure, despite the temperature being very high, the material which constitutes this inner core, it remains a solid. It does not convert into liquid. So you need to remember this, right? So this is what lithosphere is all about. Then let us have a look at the hydrosphere. Now you know this is just a rough idea, just a photograph used to give you a rough idea as to what hydrosphere is. The blue part seen here is basically the hydrosphere, and this provides water to us. So this hydrosphere part, the blue part which is seen here, the water bodies, be it the oceans and the seas, or be it the inland water bodies, which are found much they are found in the continents. They are located within the continents, while the oceans and the seas are generally found outside the continents. So inland water body, maybe for example a water body here would be called an inland water body. So the river which is flowing here, or the pond which is there, or the lake which is there, these are called inland water bodies. So hydrosphere consists of these inland water bodies plus the oceans and plus the various seas which are there. Is this fine? Now for example, this is the Arabian Sea, and you know that this is the Atlantic Ocean. So all these comprise the hydrosphere. It provides water to us, for consumption purpose, for household use, washing and cooking, for agriculture. Without water you cannot think of growing plants. The agriculture is just not possible without water. And likewise for industrial use also we require water. There is a lot of water which is consumed by industry. Then the organisms which are found in water, the aquatic plants and animals, for example fish, they also are rich food source and rich source of protein for the human population. So they also provide food to us. Again, the water which flows in the river, that can be collected in a reservoir, in a big reservoir, and then that stored water can be used to run turbines and to generate electricity. So for generating hydroelectricity also, hydrosphere is very, very important. Hydrosphere in fact is providing us this service. We are able to use the water available in the hydrosphere to generate electricity. Then if you look at the hydrosphere, you will find that it covers 3/4 of the earth's surface. So the surface part of the earth, 75% of the surface of the earth is covered by water. Though in this particular picture you might feel like the greener part or the land area seems to be much more than the bluer part or the water area, but that is not exactly the case. 75% of the earth's surface is covered by water, and out of this 75%, but the problem is that out of the 75%, 97% is in the oceans and the seas, and it is not fit for consumption, for human consumption. We do not have any technology as of now to make saline water in which salt concentration is very high, fit for drinking. So we cannot make it fit for drinking, and so it is not possible for us to consume this saline water which is available in the oceans. However, the fresh water that is available in the glaciers, in the surface and the groundwater, these are fit for human consumptions, and we make use of this water for human consumption, right? So the problem is not the availability of water. The water is available on earth, but the problem is the amount of water, the proportion of water which is available, which is fit for consumption, is only 3%, and that is available in our glaciers, in water bodies. Now what is the difference between surface and groundwater? Surface water bodies are visible by naked eye. I mean, they are available on the surface. The water which you can see flowing on the surface is basically surface water. The pond, talab, the lake, jheel, the river, they are all examples of surface water. Then the groundwater is one which is beneath the surface, which you cannot see, and if you want to harness it, you will have to, let's say, dig a well or use a submersible pump. So you have to dig a well, kuआं खोदना पड़ेगा, then only you would be able to get that particular groundwater. So groundwater which is available beneath the ground, while the surface water is on the surface, and that is the difference between the two. However, the fresh water, 3% only is available for and fit for human consumption, and we don't have any technology to convert this saline water which is available in oceans into water fit for consumption. If we are able to develop this technology, then probably water would not be a problem, but till that point of time, the scarcity of water can be a big problem for the humankind. It has been said that the third world war will be fought for water, right? Now let us talk about how it is continuously renewed. We have seen in the seen in the hydrological cycle that we discussed a little while ago, that through evaporation the water, the liquid water, gets converted into vapor, and then it reaches the atmosphere. From atmosphere, in the atmosphere, this vapor, it condenses and forms cloud, and then the clouds, the water that collects in clouds, then it falls down on earth in the form of precipitation. It could be snowfall, it could be rainfall. So this is how this water keeps on moving from the land to the atmosphere to the water bodies and keeps on getting renewed. So this is a continuous cycle. Now let us talk about the atmosphere. Now this is a picture of the atmosphere. See, this is the troposphere. Troposphere exists up to 10 kilometers. So the troposphere would end at a height of 10 kilometers from the Earth's surface. Now this is the Earth's surface. You can have a look here. This is Earth's surface, and this is where most of the human population resides. So at a height of 10 kilometers, you would find troposphere ending. From 10 kilometers to almost 50 kilometers, the second layer is called the stratosphere. Right, the first layer was the troposphere, the third layer is the mesosphere, from 50 to almost 80-85 kilometers, and from there to 600 kilometers is thermosphere, and from there it is called the outer atmosphere, exosphere. It starts at a height of 600 kilometers and goes beyond that. Now if you look at the aircrafts, they generally move in the troposphere. Only seldom do they reach the stratosphere. If you talk about the ozone layer, it is available in the stratosphere. Now please remember these points, right? And if you talk about the meteors and meteorites, they get burnt when they reach this particular part of the atmosphere, and that is why they seldom cause any damage to us, to the human population, to the Earth's surface, because most of them, they get burnt while they enter this part of the atmosphere, this layer of the atmosphere, and they get burnt because of friction. And if you talk about the satellites generally operate at this height. They operate generally at thermosphere and exosphere. And if you talk about a geostationary satellite, it would be operating at even greater heights of 36,000 kilometers from the Earth's surface. So now this is just to give you an idea of how and what all layers are there in the atmosphere. Now what is the function that the atmosphere plays? It provides oxygen for respiration so that we can breathe. For photosynthesis, oxygen is part of the carbon dioxide which is used in photosynthesis by plants to produce oxygen and food for consumption. So photosynthesis process also cannot take place without oxygen, and here we are talking about the oxygen element, not O2. We are talking about O, and this is oxygen, the molecule. We are not talking about this. So this oxygen actually is a part of this carbon dioxide molecule. Again, oxygen is also required for combustion. So if you want to heat up something, if you want to burn something, you cannot burn it in the absence of oxygen. So the atmosphere provides us oxygen for all these purposes. Then again, we have talked about the ozone layer, which is there in the stratosphere, which extends from 10 to around 50 kilometers. Now the ozone layer is found here. Now ozone layer is very, very important. The formula for ozone is O3. So one molecule of ozone comprises of 3 atoms of oxygen element, right? So now ozone absorbs UV light, ultraviolet light, which we receive from the sun's rays. If you do not have an ozone layer, what would happen? These UV rays would reach us and they can cause various problems, including skin cancers. Again, in the atmosphere, because of the differential warming of different layers, and what I'm trying to tell you is the atmosphere is being warmed by sun and the sunlight, but the warming is differential in nature, which means the amount of warming would be different in this particular layer, different here, and different in other layers. Plus, within the troposphere also, in some parts the warming would be different, in some other parts the warming would be different. I'll give you an example. Let's say the sun is here. So you can understand, in this case, the warming would be higher here and a little less here, because the sun's rays will have to travel a longer distance to reach this part. So the warming would be much less here, the warming would be much higher here. Now, because of this differential warming, what happens? We have variation in temperatures. There are colder regions and there are very hot regions also. There are rainfall variations. If you go to equator, you would find almost every day there would be rainfall. If you go to cold deserts like the Tibetan, like the desert in the Mongolia, if you go Gobi Desert in Mongolia, you would find it's a cold desert. So the rainfall variations are also there. Some parts, for example, in some parts of western India, somewhere around Rajasthan and Gujarat, you would find the rainfall is much less than 25 centimeter per year, while then there are places like Meghalaya in India which receive a very high rainfall. So there are temperature variations, there are rainfall variations, and because of this the whole global climate is sustained, right? So this is the importance of atmosphere. Now let us talk about biosphere. Now what is biosphere? Biosphere is that layer where life exists. Life cannot exist anywhere else. Wherever life can exist, that particular portion is known as the biosphere. Now have a look at this particular. The life cannot exist in the whole of the atmosphere. Life generally does not exist. If you go to mesosphere, you would not find any living being there, not even any microorganism, no bacteria, no viruses. Again, if you go to a depth of 500 kilometers, lithosphere, you would not find any life. Again, you would go to a great depth in hydrosphere, you would not find any life. So life is only possible in the biosphere. Biosphere is also known as ecosphere, right? So this is the thin layer where the life can exist. Now have a look at this. What I'm trying to tell you is this is the lithosphere, the brown part, and beyond this life is not possible. That is what we are saying. So at a great depth the life is not possible. At a great height in atmosphere the life is not possible. You can only find living organisms up to a particular height. If you go, let's say 200 kilometers, if you start entering the exosphere and the ionosphere, you would not find any life. Likewise in water also. So this area, and this is a very thin layer of almost around 30 kilometer radius, in this sphere only the life exists. All the life exists in this particular sphere only. It does not exist beyond this sphere, and this particular sphere is known as the biosphere or the ecosphere. Now what is this basically? These are the remains of the dead plants and animals, right? Okay, so biosphere provides food and water for all forms of life, not only for human beings. It provides fuel. We have talked about the coal and the crude oil and the natural gas. It provides timber, wood, and it provides materials which are required in industry, and that is why they are biosphere is very important for us. Now let us talk about one problem with the natural resources, and that problem is the unequal consumption. What do we mean by this? Let's have a look. There are high resource consumption regions in the world which consume a lot of natural resources. These include the developed world, which we know as the North. North basically is the term used to refer to the developed world. The reason is that most of the developed countries are situated on the north of the equator, be it America, be it countries like Britain, be it countries like France and Germany and Italy and Canada. Most of them are, and also Japan, most of them are located at the north, except for Australia, and that is why we call it the North. The developed world is also referred to as North, and they have a very high consumption. They consume a lot of resources. The reason is that their lifestyle is such that requires a lot of resources. For example, their diet comprises of meat, which requires a lot of resources for its production. Again, the diet also is the diet does not include a lot of vegetables. Again, the lifestyle is also energy intensive. They use lots of ACs, lots of power backed equipments, and that is why the lifestyle is energy intensive. So naturally they are going to consume more energy. On the other hand, India and China also consume a lot of energy, a lot of resources, but the point is that they do this because they have a large population. If you talk about India and China, they together comprise almost 1/3 of the population of the earth, and this is the reason why in India and China consume a lot of resources. We'll continue this discussion tomorrow. Because of some technical problem with my laptop, I would not be able to continue this discussion tomorrow. I'll take it forward from here in the next session. Thank you.